Hello students, this is Mrs. Denton, and I'm going to do a walkthrough of some information from the G.6 standard in the geometry SOLs. And this SOL, it's all about congruent triangles. G6 is all about congruent triangles, and there are three things that we are required to be able to do. It says the student, given information in the form of a figure or a statement, will prove two triangles are congruent. There's that word that students fear sometimes. We're going to have proofs in this section. And here are the three ways we have to be able to work with proving two triangles are congruent. We have to be confident in our algebraic methods, coordinate methods, and deductive proofs. There's that word again. Here is the section that proofs pop up. Okay? So let's first look at part A here, our algebraic methods. Here's a little bit of foundational information to understand about congruent triangles. There are 5 different postulates and theorems that can prove that triangles are congruent. And I've drawn them out here. We've got where 3 sides of one triangle are congruent to 3 other sides of a triangle. We've got 2 sides and the included angle. Now this part's really important. The 2 sides must, whoa, that was a weird noise. The 2 sides must surround the angle. Okay, see how that angle is between the 2 sides that are congruent? All right, so this side matches this side, and this side matches this side, and the included angle. That's abbreviated SAS, side, angle, side. Then we've also got where we could have 2 angles in a side, and check out where the S is in this abbreviation, angle, side, angle. So here, the side is between the congruent angles. We've got 2 sets of congruent angles and a side that connects them. Okay. You can also have the situation where you have 2 angles in a side, but the side is not included between the 2 angles. So here we have 2 congruent sides, 2 congruent angles, 2 sets of congruent angles, and then the side involved is not connecting the 2 angles. Okay, that would be called angle, angle, side. And then last but not least, we have a special case called HL, which stands for hypotenuse leg. And of course, this can only be for right triangles. Okay, because it's got to have the hypotenuse and the leg. So once you know that a set of triangles are congruent, you can write out a congruent statement. So I'm going to give you an example. Let's say that triangle ABC is congruent to triangle XYZ. Okay. If we know that triangle ABC is congruent to triangle XYZ, this is called a congruent statement, then we can start pulling it apart and matching up each of the parts. So angle A, which is listed first, would match up with angle X, which is also listed first. Here, the order of how you write the triangle congruence matters. And then we've got triangle B listed second, matches up with angle Y, also listed second. And then finally, we've got angle C listed third, matches up with angle Z, also listed third. So we can match up the corresponding congruent angles. Corresponding means in the same position. So A is the first, X is the first. B is the second, Y is the second. C is the third, Z is the third. So those are corresponding angles, and they now are listed out to be congruent. We can do the same thing with sides. It's a little trickier. Here we've got side AB, which is in the first and second position, and that would be congruent to the side that's in the first and second position, which is XY. So side AB would be congruent to XY. side BC, that's the second and third position, would match up with side YZ. And then finally, side AC, which is the first and third position, would match up with side XZ, which is also in the first and third position. So we can take a congruent statement and break it into 6 different congruent parts. This is abbreviated, that funky CPCTC. Anybody remember what that stands for? That stands for congruent parts. I'm sorry, let me start over. Corresponding parts of congruent triangles are congruent. And that's what we're doing here. We're taking the congruent statement and breaking it apart to list out all of the corresponding congruent parts. Okay, let's see what might be asked of us here. I've got some examples here I've pulled off of previous SOLs. It says, which postulate or theorem can prove that the two triangles are congruent? So we are working on proving, but we're just using this algebraic method, this pattern recognition. So let's check out the first one. B is a midpoint. Oh, there's such an important word right there. We have to know what a midpoint is. It says B is a midpoint of side AC. Here's side AC, and B is a midpoint. And we should know that that means that B is right in the middle of this line. Therefore, AB and BC would be congruent parts. AB and BC are now congruent. AB is congruent to BC. All right, so that's one thing we get out of that word midpoint. We're also told right here that angle A is congruent to angle C. I'm going to mark that. Angle A is congruent to angle C, and that's here in the given information. Now there's one more piece in the picture that should be marked and noted, and that is we have this like bow tie set of triangles. We call this a bow tie in my class. And anytime you have a bow tie, you can also include the vertical angles as a set of congruent parts. So don't forget the vertical angles. Okay, so we've got angle A and angle C. That was given. That's a set of congruent angles. We've got AB side and BC side congruent due to the midpoint. And then we've also got the two sides of this vertical angle. That would be angle ABD and angle EBC. So it looks like I have a side and two angles. One side and two angles. So I've got two different options of postulates here. I've got ASA, angle, side, angle, or AAS, angle, angle, side. And it just depends on what the picture looks like. Let's check out where the side is. Notice that the highlighted side is connecting the two angles for each triangle. So that's called an included side. So I'm going to use ASA postulate. These two triangles are congruent by ASA. Now you have all these drawing tools on your SOL, so you can highlight, you can draw, you can mark it, or you can just grab a piece of paper, recreate the image, and do it yourself on paper, and that would be a really great technique. Let's try another example here. Here's the picture. Okay, there's our two triangles, and here's our given information. AB is congruent to CD. I'm going to draw that out. AB is congruent to CD. AB is congruent to CD. So that's our first part of congruence. Then we've got BC is congruent to AD. BC is congruent to AD. Okay. Now something else that's in this picture that we can add in, it doesn't have to be given to us, is this shared side here. We've got BD that's part of both triangles. It's part of the lower triangle and it's part of the upper triangle. It's the third side to both of those triangles. That's called a shared side. So we can definitely include the shared side. You'll just have to draw that in yourself. Kind of like the vertical angles over here. So now we've got that side BD is congruent to itself. We'll take a look at what you've got up here as the three congruent parts. You can either look at your picture or look at your list. You've got three sets of side congruences. So we have the SSS situation. Three sides on one triangle are congruent to three sides on another triangle. So these two triangles are congruent by SSS. All right. It seems that we have the exact same picture here for my third example. So look carefully. Our given information has changed. We start out the same way. Side AB is congruent to side CD. AB and CD are congruent side lengths. And then it gets switched up a little bit. We're told that AB is parallel to CD. Got that parallel symbol in there. Okay, so parallel, I'm putting my parallel symbols on here, these filled in triangles. You guys, anytime you've got that word parallel, you can go way back to what we covered in SOLG 2 about parallel lines, which means we've got all kinds of angle relationships formed. And in a picture like this, I can guarantee that the angle relationship being formed is going to be an alternate interior angle. Now we just have to be able to identify where that alternate interior angle is. So I'm going to grab a pencil here. If you extend these lines, maybe that'll help you. You can build out the lines a little longer, build out the transversal line a little longer, and maybe it'll be easier for you to identify what angles are parallel, what lines are parallel and what angles are alternate interiors. So we've got these two lines as parallel and this as the transversal. Okay, so the angle in here that would be an alternate interior that uses the parallel lines and the transversal would be at angle B, the bottom portion of angle B, and the top portion of angle D. Those are going to be our our alternate interior angles, and they're going to be congruent due to these parallel lines. So that's something that we've got to draw in here. Alternate interior angles. So now I know that angle ABD is congruent to angle CDB due to those alternate interior angles. We also have that shared side in there again, just like we had over here. So we can mark that as congruent to itself. So BD is still congruent to BD. It's a shared side. So there's a lot going on in this picture that we have to add in based on the picture or based on the given information. We've got two sides and an angle. Two sides and an angle. Now, if I look up here at my list, this is the only option, side, angle, side. That's two sides and an angle. So we want to verify that the angle is between the two sides. It's included between the two sides. So come on down here to our picture. Maybe cover up one of these triangles. And indeed, angle D is between our two highlighted sides. And on the second triangle, angle B is between our two highlighted sides. So this is proven by side, angle, side. Okay, our fourth and final example here is a set of triangles that are butted up against each other. The given information is in the drawing this time. It's not written out for us. So let's take a look at the drawing very carefully. We have one set of congruent angles at C and another set of congruent angles at B. And it seems as though that's not enough information, but if we go back to these other two pictures we've studied, we are told to include the shared side. The shared side here can be included as a congruent piece. So we've got side BC congruent to itself. We've got these two upper angles congruent and these two lower angles congruent. So we have two angles and a side. So again, we have options. Two angles and a side could be ASA, or two angles and a side could be AAS. It truly depends on where the side is. Notice that the side is connecting the two angles. So this is another example of ASA. Okay, I'm going to stop here with this video. This will be the end of part 1. Our next video is going to look at some more solving techniques using algebraic methods. So come back if you need help with that. Thank you.